Hi guys, these are the notes for 1.7, writing proofs. What we're going to start off with is a review of vocabulary. This says look at the equations below and think about what you would do to solve for the variable. Fill in the letter of the correct property of real numbers that matches what you would do to solve it. All right, so if we look at this one, grab the pen out. Right, we have 5 equals x plus 7. So in order to isolate the x or solve for it, we're going to subtract 7 to both sides. Right? When we subtract something, that's called the subtraction property of equality. So D, subtraction property of equality. The next one, we have to add 12 to both sides to isolate y. So if we're adding, addition property of equality. The next one, we have 8 times z. Well, to get this equal to 1z, right, we need to divide both sides by 8. So division property of equality. And then the last one, right, to get this 1/3 w, right, we need to multiply by the reciprocal. So we're multiplying by 3/1 to both sides to get rid of that 1/3 w, right? So that means we're using the multiplication property of equality. Okay, so you think about these ones, the property of equalities or the property of real numbers. It's whatever action you're doing to solve for that variable represents that property, right? So if you're subtracting, right, subtraction property. If you're multiplying, multiplication property. All right, now what we're going to do is we're going to set up this thing called a 2-column proof. All right, so you can see there's 2 columns to this chart, and we're going to set up a 2-column proof to solve the following equation, okay, for x. Well, what we're going to do is we're going to solve it on the left side like you normally solve an equation for x, like a multi-step. Now, on the right side, you're going to write a justification for that step, okay? So what you just did to it using a property of equality that we just went over, okay? So our first step to solving this equation in question 1 is to get rid of this denominator. Well, how do we do that? We need to multiply this denominator by 3, right? And that will cancel it out, and multiply the other side by 3, okay, to keep it constant. So to cancel this out, right, we use the multiplication property of equality. Okay, and I'm going to abbreviate this a little bit so it fits. Now, our next one, right, once we use that and cancel out that denominator of 3, we get 2x plus 5 is equal to 27. Our next step is to get rid of any addition or subtraction. Well, we have an addition of 5. So to zero that out, we subtract both sides by 5. So we're using the subtraction property of equality. Right? So we're just explaining what we did to get to this third step. Right? We subtracted each side by 5 to get to 2x is equal to 22. Okay, and then the last step, we divide both sides by 2 to get x equals 11, right? And we divide it, so it's division property of equality. Okay, so essentially writing proofs is what we're doing is we're solving a problem on the left side, and we're just given the exact reason on why we can solve it, right? The justification for the step, why we can do these things, because we know we can subtract 5 from each side by the subtraction property of equality, right? So that's essentially what we're going to do in this section. All right, so the next thing we're going to go over, so those were the properties of equality. The next one of operations, this one's the transitive property of equality. So what it says is it's saying if A equals B and B equals C, then A equals C. Okay, so essentially, right, if A equals one thing, and that one thing equals another thing, then A equals that third thing. Okay, so if the first thing equals the second thing, and the second thing equals the third, then the first equals the third. Essentially what it's saying. Okay, now we have a property of congruence, so we use this when talking about congruence of like segments and angles and things like that. So it's going to essentially be the same looking thing, but it says if A is congruent to B, capital A is congruent to capital B, and capital B is congruent to capital C, then A is congruent to C. Right, essentially the same thing, but we know we're going to go over how congruence is technically different than just an equal sign. Okay. All right, now we have the definition of a proof. Okay, so like I said last time, last problem we went over a two-column proof essentially. So a proof is a convincing argument that uses deductive reasoning most of the time. And the format which we just went over is usually a two-column proof. All right. Another thing, we're not going to use just properties for proofs. We're also going to use theorems to help us. And a theorem is a conjecture that has been proven to be true. So we can use that as one of our reasons for doing something. Okay, so it would be one of our right things would be a theorem. Okay. Now, a last definition before we go through some useful theorems would be a linear pair. So a linear pair is just two angles put together that form a line. Okay, so a picture of this, right? Say we have this angle right here, right? And we call this angle 1, right? And we have another angle right here from there to here. And we call this angle 2. If we see they make a straight line, these two angles, so angle 1 and angle 2, are a linear pair. All right, now we're going to go over some useful theorems. The first one is called vertical angles theorem. Okay, this tells us that vertical angles are always congruent, meaning they have the same angle measure. So if we look, right, hypothesis, right, which one of these angles are congruent? 1 and 2, 1 and 3, or 3 and 2? Well, it's vertical angles are opposite or never touching. So if we look at angle 2 and 3, right, they're touching. So 1 and 3 and 3 and 2 are touching, right, and they're not opposite each other, so they cannot be vertical angles. But if we look at 1 and 2, they're opposite each other and they're not touching. So we can say angle 1 and angle 2 are vertical angles. I abbreviate angles like that. And angle 1 is congruent to angle 2. The next theorem is the congruent supplements theorem. This says if two angles are supplementary to the same angle or congruent angles, then the two angles are congruent. Supplementary means that it adds to 180 degrees. Okay, so, right, if we look at our hypothesis, we're saying that if angle 1 plus angle 2 equal 180 degrees, then if angle 3 plus angle 2 equals 180 degrees, then angle 1 must be congruent to angle 3 because when they both add to 2, they equal 180 degrees. All right, so the next one is the congruent complements theorem. So very similar to supplements theorem, except complements or use complement. Sorry, I spelled that wrong. Complementary angles, and complementary angles means it adds to 90 degrees. So pretty much the same concept, except it's adding to 90 degrees rather than 180. So, right, if angle 1 plus angle 2 equals 90 degrees, and angle 2 plus angle 3 equals 90 degrees, then angle 1 must be congruent to angle 3. All right. The next one, right, is right angles theorem. So you should know a right angle is 90 degrees, right? And this just tells us that if two angles are right angles, then they are congruent, or all right angles are congruent. So we can say angle A is congruent to angle B because they are both right angles. Right. Next one is congruent supplements theorem. Okay. So the congruent supplements theorem tells us if two angles are congruent and supplementary, then each is a right angle, right? So if 1 and 2 are congruent, right, that means they're and they're supplementary, that means they're both half of 180, then they both must be 90 degrees, or they both must be right angles. So we can say angle 1, is equal to 90 degrees, and angle 2 is also equal to 90 degrees, because if they're the same degree and they both add up to 180, they both have to be 90 degrees. Okay, and then the last one is linear pairs theorem. This tells us the sum of the measure of a linear pair is 180 degrees. So we went over the definition of a linear pair before, where a linear pair is two angles that form a line. Okay, and if so that tells us the linear pairs theorem tells us that the sum of the measures of the linear pair is 180 degrees. So that just means if we add the two angles together, they equal 180 degrees, right? So we can say angle 1 plus angle 2, so the measure of them, so I'll put the little m, is 180 degrees because they are a linear pair, right? So whenever you are told something's a linear pair, we're told those two angles add up to 180 degrees. So that's the end of all our theorems and our postulates to help us in this section. What we're going to do next is we're going to fill out a 2-column proof that proves the vertical angles theorem. Okay, so we're given pieces of the statements and the reasons of this. Okay, so what we're going to do is fill out the missing pieces of the statements and missing pieces of the reasons. Okay, so the first one says we're given, right? So we're given this. So we always write our first step as the given. Okay, so first step is always given. So we're given that angle 1 and angle 2 are vertical angles, right? If we're given their vertical angles, well, what does that mean? Well, that means that they're congruent to each other, right? And that's what we're trying to prove. Okay, so if we look at our reason for number 2, right, that's going to help us draw our statement. It tells us our reason that we're writing this is their supplementary angles. Well, we know supplementary angles, right? They add to 180 degrees. Okay, so supplementary angles add to 180 degrees. That means if we add 1 and 3 together, it's going to equal 180 degrees. So angle 1 plus angle 3 equal 180 degrees. Okay. And also, if angle 2 and angle 3 are added together, right, then they're supplementary angles and they equal 180 degrees. So angle 2 plus angle 3 equal 180 degrees. Okay. Now the next step, our statement is that angle 1 plus angle 3, right, we brought that down here, is equal to angle 2 and angle plus angle 3. Okay. Now, this is because if our first statement, right, angle 1 plus angle 3 is equal to our second statement, 180 degrees, and our second statement, 180 degrees, equals our third statement, angle 2 plus angle 3, then our first and third statement are equal to each other. So if we remember back, that is the transitive property of equality. Okay. The next one says subtraction property of equality. So, right, we need to use the subtraction property of equality to, sorry, these should say measure of angle 1 plus measure of angle 2, and measure of angle 2 plus measure of angle 3, because the measures add up to 180 degrees, right? And then so if we use the subtraction property of equality, right, and we subtract measure of angle 3 from both sides, right, we're going to get the measure of angle 1 equals the measure of angle 2. And that's essentially almost what we want to prove. Angle 1 equals angle 2, but there's one more step. And we can prove that angle 1 equals angle 2 when the measures are equal to each other by the definition of congruent angles. Right? That tells us that if the measures are equal to each other, then the angles are congruent to each other. Okay, so that's how we are able to prove the vertical angles theorem. All right, and then the last example we're going to do is we're going to fill out a 2-column proof given something and then proving something. Okay, and we're going to do the same thing. We're given some of the statements, we're given some of the reasons, we need to fill in the blanks. Okay, so our given is that angle 1, measure of angle 1 is equal to the measure of angle 2, right? And the angle of measure 1 is 105 degrees, okay? So, right, by our given, right, one of our givens was measure of angle 1 equals measure of angle 2. We're also given that measure of angle 1 is 105. So this is also our given here. That's why 1 and 2 are both our given. Now, right, because our first statement, measure of angle 1 equals our second statement, 105 degrees, and then 105 degrees equals our third statement of measure of angle 2, by the transitive property of equality, okay, the measure of angle 2 equals 105 degrees. Now, we could also use the fact this could also be the substitution property of equality. Right, what do I mean by the substitution property of equality? This tells us that if we know measure of angle 1 equals measure of angle 2, and measure of angle 1 equals 105 degrees, we can substitute in 105 degrees for measure of angle 1, and that's how we get the statement measure of angle 2 equals 105 degrees. All right, now the next step says that angle 2 and angle 3, so 2 plus 3, sorry, 2 and 3 form a linear pair. So that is by the definition of a linear pair. Okay. The next one, we use the linear pairs theorem to figure out our fifth statement, right? And we know by our linear pairs theorem that if they are a linear pair, then the measure of angle 2 plus the measure of angle 3 add up to 180 degrees. Okay. The next one, right? This is a good example of our substitution property. We know the measure of angle 2 by statement 3 equals 105 degrees. So we can substitute in 105 degrees for measure of angle 2 into this statement here. Okay, so that's by the substitution property of equality. And then the last step is the subtraction property of equality. So we're just subtracting 105 from both sides to get that measure of angle 3, which is equal to 75 degrees, which is what we were trying to prove. Therefore, we are done. Okay, so we figured out all the statements and using all the reasons to prove this proof of that measure of angle 3 equals 75, given these two things here. Okay, guys, so if you have any questions on this, let me know. Once you get into the Math Excel and things like that, it should be getting easier the more you do of them, the more you do. But you want to keep a hold of those theorems and those certain properties of equalities and kind of get used to them for this section.